Let's begin this lesson with a little review of taking a function of a function. So here we are looking for f of g of x, which means I'm going to take this inner function here and put it into the outer function. Now this also could be written as f of g of x. So I'm taking f of whatever g of x is, which is x minus 7. So I'm going to be taking this g of x and plugging it into the x here for f of x. Okay, so that equals that x, which becomes x minus 7 squared plus 4. Okay, x minus 7 squared. So when I square a binomial, I take the first term squared. I take double the product of the two terms. The product is negative 7x. Double that is negative 14x. And then the last term squared. So x minus 7 squared is x squared minus 14x plus 49. And then I still have a plus 4. X squared minus 14x plus 53. Then find f of g of 10. So that could be written like this, f of g of 10. Okay, so I need to find out what g of 10 is. So g of 10 is actually 10 minus 7. So I'm really finding f of 3. So f of 3 is 3 squared plus 4. So that's 9 plus 4, and 9 plus 4 is 13.
Welcome back once again. Today we are going to deal with domain of a composition of functions, and specifically the type of composition where we are taking a function of a function. So for these first 5 problems, we are going to find the domain of f of g of x. So I'm going to show you one way that this can be done. We're going to consider this right here to be the inner function. And the first step we're going to take is to find the domain of the inner function. So the domain of g of x. Now if this was switched around and it was g of f of x, so the f was right here, then we would be doing f of x first. So the domain of g of x. There's a variable, but there's no variable in a denominator. There's no variable under a radical. So x can be all real numbers. I'm going to circle that just because it's going to become part of my final answer. Step 2, we're going to take the domain of the outer function. So the domain of f of x. And once again, I do not have a variable in a denominator or a radical. So the domain of f of x is all real numbers. Now this right here tells me whether I need a step 3 or I stop at step 2. If you get all reals for your domain of the outer function, then we're going to stop right there and write our final answer. So our final answer is this right here, what we got in step 1. So the domain of f of g of x is all real numbers. On number 2, once again, the inner function is g of x. Domain of g of x. And I do not have a variable in a denominator or a radical. So that is all real numbers. And I'm going to circle that because I'm going to use it in my final answer. For f of x, there's a variable under a radical. And what's under a radical cannot be negative. So this right here, this x minus 3, has to be greater than or equal to 0. I'll move that over, so x has to be greater than or equal to 3. The fact that this is not all reals tells me I need to move on to a step 3 where I find the domain of f of g of x. Okay? And the quick way to do that is to steal something from 1 and 2. From 1, I'll take g of x. From 2, greater than or equal to 3. So g of x is x minus 7. So x minus 7 has to be greater than or equal to 3. And when I move that minus 7 over, I get x is greater than or equal to 10. And I'm going to circle that. When I have a step 3, I'm going to use that in my final answer as well. The domain of f of g of x, or g of f of x, or any function of a function, must satisfy two things. When we overlap them, the domain will have to satisfy the domain of the inner function and the composition. So the domain of f of g of x, which by the way is the exact same thing as what's written right here, f of g of x. This is just a more formal way of writing it. Is the set of all x, which is reals, so our step 1 is covered here, such that x is greater than or equal to 10. So the set of all x takes care of reals, and x is greater than or equal to 10. We've got the inner function and the composition covered in our domain. In number 3, the inner function. Domain of g of x. I've got a radical, and what's under it has to be greater than or equal to 0. So x is greater than or equal to 3. I'm going to circle that because that's part of my final answer. For f of x, domain of f of x. No variable in a denominator or a radical, so x can be all real numbers. And the fact that step 2, the outer function, is all real numbers, tells me I can stop. The domain of f of g of x is the set of all x such that x is greater than or equal to 3. Number 4, step 1, the inner function, domain of g of x. I have a radical, and what's under it has to be greater than or equal to 0. So x is greater than or equal to negative 5, and I'll circle that because that's part of my final answer. Step 2, domain of the outer function, f of x. I've got a denominator with a variable in it, and a denominator cannot equal 0, so x cannot equal 3. That's not all reals, so that tells me I need a step 3 where I do the composition. Domain of f of g of x. And here's where I steal from steps 1 and 2. G of x cannot equal 3. So g of x is the square root of x plus 5. That cannot equal 3. So I'll square both sides and get x plus 5 cannot equal 9. And then I'll subtract that 5, so x cannot equal 4. And I'm going to circle that, and I'm using what I got in steps 1 and 3, the inner function and the composition. So the domain of f of g of x is the set of all x such that x is greater than or equal to negative 5, but x does not equal 4. So for our next one, the domain of the inner function, g of x. No variable in a denominator or a radical, so that's all real numbers. and I'm going to circle it because I will use it in my final answer. Step 2, the outer function. I've got a variable in a denominator. 5 minus x cannot equal 0. I'm going to move that x over to the other side. So 5 cannot equal x, or x cannot equal 5. And that's step 2. It is not all reals. That tells me go on to a step 3. And I steal from step 1, g of x, and from step 2, cannot equal 5. So the domain of f of g of x cannot equal 5. So that's x plus 2 cannot equal 5. And we'll subtract that 2. X cannot equal 3. So the domain of f of g of x is the set of all x such that we've got all reals. That's the set of all x. X cannot equal 3. So that is one way to find the domain of a composition of functions. In our next lesson, we'll practice this way again, but we'll also see another way. In our last question here, find the first 3 iterates. So this is related to what we've been doing here with composing functions, because an iteration is when you compose a function with itself. In this case, we've got a function here, and its initial value, x sub 0, or the 0th iterate, has a value of 1. To find the first iterate, x sub 1, what we have to do is f of the 0th iterate. So that's 3 times 1 squared minus 1. 1 squared is 1, times 3 is 3, minus 1 is 2. So x sub 1, the first iterate, has a value of 2. So to find x sub 2, we take f of the previous iterate, which is 2. So it's 3 times 2 squared minus 1. 2 squared is 4, times 3 is 12, minus 1 is 11. So the second iterate has a value of 11. So the third iterate, x sub 3, is f of the second iterate, which had a value of 11. 3 times 11 squared minus 1. 11 squared is 121, times 3 is 363, minus 1 is 362. So the third iterate is 362.